This video will walk you through running and interpreting a regression with a dummy variable with an interaction term. So I'm back to the Harris 7 data, and I've already gone through and I've run my regression to evaluate salary based on years of education, months of experience in the field, months with the firm, and a dummy variable for gender, which I'm calling males, that takes a value of 0 when the person is female and 1 when the person is male. And I've gone through and I've looked at this, and I see that gender does have a statistically significant impact on pay. My interpretation was that males make on average $722.46 more per month, and after conducting a specific hypothesis test, I do know that that gender does in fact have a positive impact on salary. Now what I want to do is create an interaction term. So basically try to figure out whether or not education and being male also has an impact on your salary. So do males with more education make comparatively more than females with that same level of education? So when I run a dummy variable regression without an interaction term, what I'm really doing is just changing the y-intercept of my regression based on whether or not that dummy variable has a hit, where a hit is where it's called, that coefficient is called into play when the dummy variable is a 1. In other words, showing that additional $722.46 for male, versus if the subject was female, I would just calculate their salary without that, because I would that 0 on males would be a miss, and meaning I'm not adding that $722.46 into my equation. But when I include an interaction term, what I'm actually doing is changing the slope of the salary. Changing the slope, because the slope on education will now actually be different for the two groups. It would be different for male and for female. So the average salary between the groups is driven by factors that cause your education to differ, if in fact I do find that is statistically significant. So by focusing on changing the slope rather than changing the intercept, I'm basically going to consolidate the effect of education into one coefficient that is different for males and for females. This will allow me to see pay differences for male and for females, but also to see how that pay difference is impacted by education. So the way I'm going to do that is to create an interaction term, and this is going to be male and education, male times ed, and it's literally just equal to male times education. So this is going to be triggered, obviously, if for every female it's going to be 0, for every male it's going to be the education variable. And now I'm going to go through and rerun this regression. Just that looks a little close to me, so I'm going to insert another row in there, or another column in there, just to neaten it up a little. So I can go into data analysis, and run my regression. My dependent variable is salary. My independent variables, so I can see, are now education, experience, months, male, and then that interaction term as well. Okay, I do have labels in there, and I want to put this output, let me just put it right below here. Okay, so here I can go and I can see that it looks like, gender no longer really seems to have a statistically significant impact, and that education education in male also doesn't really have a statistically significant impact anymore. But in order to really evaluate that, what I would have to do is go through and run a partial F test. So this would be considered now my full model, and I would need to go ahead and run a reduced model, which would not include those two new terms, in order to now see the impact of male, because now male, that, being male, that impact of gender is now spread over two variables. So I'm going to go through and rerun that regression, still with my same dependent variable, but now my independent variables I'm not going to include. Come on, scroll over. I'm not going to include the dummy or the interaction. Okay, and let's just put this right below so I can see. And this will be my reduced model. Okay, so in order to run that, I'm going to need to do my partial F test. So full, I need my SSE full, my SSE reduced, and then I need N, K, and L. So my SSE full, sum of squared errors from my full model is SS residual from my full, and then sum of squared errors from my reduced model is right down here, sum of squared errors residuals from my reduced. N is the number of observations I have in my model. In both cases, that's 93. K is the number of independent variables I have in my full model. And L is the number of independent variables I have in my reduced model. So my F statistic. Okay, for my F comparison test, my numerator here is sum of squared errors from the reduced minus from the full divided by K minus L. And then all of that is going to be my numerator divided by sum of squared errors from my full divided by N minus K minus 1. And I'm going to compare that to my F crit, which is equal to F inverse, my probability, which is 0.05. First degrees of freedom is K minus L. And my second degrees of freedom is N minus K minus 1. Okay, close that off. And here, my F stat is greater than my F critical, so I'm going to reject HO. And HO was that my new independent variables didn't add to my regression. So by rejecting that, I'm saying that there is, that males and education do belong in my model. They should have a statistically significant impact in there. So really what this is showing then, if I look at the interaction of males and education, it's saying that when male is 1, then that education factor is going to be triggered. Otherwise, if male was 0, meaning the person was female, then this term would not come into play. So it's saying that for each additional year worth of education, a man's monthly salary will increase by roughly $81.89. A female's salary would not. So this is basically showing we already know that men on average earn more. And this is just showing that interaction term to see the impact of the relationship between gender and education. Now, it's really interesting because when I look up on here, I had a positive coefficient on males, and I do know from my initial statistical test that I did have a positive impact, that males do in fact earn more. But now I'm seeing that is in fact a function of their amount of education. So the more education a male has, the more money that they actually earn. And I can go and I can do this same thing in SPSS. So I'll bring this data up. Okay, and I'll need to go and create, let me just pull this over more so we can see it. I'll need to go and I'll need to create a new variable. So transform compute variable, and this is going to be interaction. Now, that's just because I'm calling it interaction instead of males times education, just as a function of the fact of how SPSS likes its labels done. It's a little more picky than Excel. All right, and that is going to be equal to males times education. And bring both of those over, click OK. Go back to my data editor window and see that it did in fact create that interaction term, and it is 0 for all of the female observations, and then equal to the education amount for all of the male observations down there. So I can go ahead and I can run that regression. My dependent is salary. My independents are education, experience in months, number of months with the firm, gender, which is males, and then that interaction term. And I'll click OK. And I'm going to get that exact same output. Now, I would still have to go through and run my partial F test, but again, after I'll conclude that is statistically, that these two new variables do add statistically to the model, I'll have that same interpretation as I found using Excel.